Water can do extensive damage to land and shoreline in an amazingly short amount of time. That's why it's critical to choose the right products when working near water. This short video shows how the Keystone retaining wall system withstands the effects of water. Recently, a major U.S. university conducted 4 separate controlled tests in their laboratory on Keystone walls without geogrid. These tests were, in order: determination of Manning's N value, test of inundation and sudden drawdown, the effect of high velocity flows, and the effects of wave action. Manning's N value is a measure of the roughness of the surface over which water flows. To determine the Manning's N value, a 45-foot section of channel was lined floor and walls with Keystone rock face units. 6 rows of compact blocks were laid longitudinally along the floor of the channel with their rough sides facing up. Next, 3 rows of standard units were laid to form the sidewalls. Discharges of 10, 20, and even 30 cubic feet per second were run through the channel. Depth and velocity measurements were taken at 1-foot intervals across the channel and at 5-foot intervals along the channel for each flow. In some applications, a retaining wall's ability to withstand inundation and sudden drawdown will be critical. To test these effects, Keystone units were laid 7 rows high and 35 feet long with radiused ends. Gravel was compacted in and behind the units. A solid bulkhead was installed downstream from the wall, and the channel was filled with water to a depth to cover the wall. When the wall and embankment were completely saturated, the bulkhead was raised suddenly with a crane, and the water was allowed to flow rapidly from the channel. Measurements were taken at several locations before and after the test runs of the distance between individual blocks in the wall and the concrete wall of the flume to determine whether or not there was any movement of the blocks as a result of the sudden drawdowns. Note how this test dramatically illustrates the ability of Keystone units to promote effective drainage. There was no detectable movement of any of the blocks, even though those on the bottom row were not fastened to the floor in any way. In applications along river embankments, a retaining wall may be subjected to high-velocity flows during flood conditions. The high-velocity flow test was performed with 2 walls being constructed face-to-face, with the inlet ends being curved into the sides of the channel. A special nozzle was installed to create the necessary flow rates. Flows of 60 cubic feet per second and 80 cubic feet per second were run through the channel for approximately 15 minutes each. The flows of 60 and 80 cubic feet per second produced velocities of approximately 18 and 24 feet per second respectively. The valve was then opened fully, which allowed 90 cubic feet per second to flow at a velocity of approximately 27 feet per second, and this was allowed to run for 30 minutes. The velocity of 18 feet per second was measured with the Matadero-Whitney electromagnetic velocity probe, which has a full scale of 0 to 20 feet per second with an accuracy of plus or minus 1%. The higher velocities of approximately 24 and 28 feet per second could not be measured with a propeller meter or pitot tube because the force of the water flow was so great that it bent every rod that was placed in it. Therefore, these velocities were calculated from the known discharge and outlet dimensions of the nozzle. In many lake and channel applications, the results of wave action are necessary in understanding the system's capabilities to withstand this force. To study this, a 5-foot-high wall was constructed at the end of the flume across the channel and backfilled and compacted with gravel. A slotted bulkhead, similar to the one used in the high-velocity flows, was installed and covered with a fine mesh wire screen to prevent the gravel from going through it. In front of this, compact blocks were placed on their side, on the floor against both walls and at the 1/4, 1/2, and 3/4 points of the channel width, for a distance of 4 feet upstream from the slotted bulkhead. The face of the wall was approximately 26 feet downstream from a solid steel bulkhead. The channel upstream from the bulkhead was filled with water, after which the bulkhead was raised suddenly to release a high-velocity wall of water against the blocks. These destructive waves were formed repeatedly over a period of several hours. From the measurement taken, and by visual observation, there was no movement of the blocks in the wall due to wave action. These 4 carefully controlled tests help prove what we've known all along. Keystone's mortarless system is the best way to build a retaining wall, no matter where you build it. If you'd like more information about how the Keystone retaining wall system could work for you, please call us at 1-800-747-8971. Keystone, wall-to-wall greatness.